Hello, my name is Manisha. So today we will study how current flows through a conductor and what is electrical resistance. So we know that in a metal, in a conductor, there are a lot of free electrons available, which are and all which are responsible for current. And these all these electrons, they are in random motion. For example, if we have a conductor like this, these electrons, these small dots, we call them electrons, so they are in random direction. And also there are atoms or ions inside the semiconductors. Okay, so the flow of electrons is which constitute current. So if we apply a potential difference across such a conductor, so what will happen? So all these electrons which are in random direction, so they will align themselves along a certain direction. So here we apply potential difference. So all these electrons, they will drift from negative terminal of the conductor toward the positive terminal of the conductor. So they will align themselves in the same direction. So the speed with which they drift is called the drift velocity of electron, and which is always less than the velocity of electrons when they are in random motion, because here when they drift, they also collide with the atoms or the ions of the conductor, and because of this collision, they experience an obstruction or the opposition. So this opposition to flow of electrons is called resistance, which is denoted by R. So if there is more opposition in the conductor, so this resistance is higher. Okay, so if the resistance is higher, there will be less current inside the conductor. So now we will see on which factors this resistance will depend. So from Ohm's law, we know that potential difference is equal to current into resistance. So this resistance is inversely proportional to I. So if we have higher resistance inside a material, so there will be less current. So this resistance, it depends upon number of factors: the length of the conductor, the nature of the material, and also the temperature of the conductor. So for example, if we increase the length of this conductor, okay, so these electrons, they will have to travel a longer path, and when they will travel longer path, there will be higher possibility of collision with the ions or the atoms. Okay, so this resistance, so if we increase the length, the resistance also increase. So this resistance is directly proportional to length of the conductor. So one thing is this. Then second is, if this resistance is also directly proportional to the cross sectional area. So for example, if we increase the cross sectional area, okay, so which if while having more cross sectional area, the possibility of collision of these electrons with ions or atoms is less because of the large area, and in this case the resistance, it will decrease if we increase the cross sectional area. Okay, cross section area. So from here we see that when we have, so this resistance is proportional to length divided by cross sectional area. So if we remove this proportionality, so we can write is rho L divided by my area. So this rho is the resistivity of a material. Okay, resistivity of a material. So this resistivity, so if we have higher resistance, then resistivity is also higher. So from this relation we can find out resistivity, resistance into area divided by length. So the resistivity of a material will increase with increase in resistance, with increase in cross sectional area of the conductor, and it will decrease with increase in the length of the conductor. And the unit of this resistivity is ohm meter or ohm centimeter. So also this resistivity, it will depend upon the temperature. So if we have, suppose if we have if we have a conductor at two different temperature, and it has a resistivity rho 1 at temperature T1 degree Celsius, if we have another resistivity at temperature T2. So from this one we can find out the temperature coefficient, the coefficient of temperature, the temperature coefficient of resistivity, which is denoted by alpha. So which is equal to rho 2 minus rho 1 divided by rho 1 into T2 minus T1. So this alpha, which is called the temperature coefficient of resistivity, it is equal to change in the resistivity, difference in the resistivity divided by original resistivity into change in temperature or rise in temperature. So this alpha, which is it can be this alpha, it can be positive and it can be negative. So for example, for in case of conductor which have because in conductors there is a lot of free electrons available, so the current is higher, so resistivity is higher so this alpha is positive in case of conductor or metals, and in case of semiconductor, and this is of the from order of 10 to the power minus 8 ohm 10 to the power minus 8 to 10 to the power minus 4. So silver is one of the material conductor which has a very low resistivity. It is of the order 10 to the power minus 8. So so this is the resistivity of the conductor. So resistivity is very low in case of conductors. So silver is one of the material which is has a very low conductivity. So is a very good conductor. So which will give a very high current. So in this case, this alpha is positive. In this case. So with it will increase. So the resistivity in this for conductor, it will increase with increase in temperature. While in case of semiconductors, the resistivity, it will decrease if we will increase the temperature. It will decrease if we increase with temperature. And so alpha in this case is negative. Similarly, so some example of semiconductors, they are which have which has resistivity. For example, for germanium it's 0.45, And in case of insulator also this temperature coefficient of resistivity is negative. So means the resistivity it will decrease with increasing temperature faster in case of insulator. So in case of insulators also this resistivity it will decrease with temperature but faster than semiconductors because here are no electrons available for conduction. So in this case also this temperature coefficient of resistivity is negative. So diamond is one of the example. So thank you very much.